My name is Abigail Ida, and this is the preliminary design review for Trynkit's web-based MicroPython development platform. The team members include Justin B., Brian Carson, Andrew Florentino, Vincent Ocha, and myself. I specifically will be discussing the project description for Team 5. First, I will provide you with some information about the Trynkit company in order to get a full understanding of the need this project fulfills. Trynkit is a company that offers web-based IDEs for embedded programming. They work to develop low-cost, open-source IoT technology that can be used to enhance STEM education as well as the maker community. Trynkit works to enhance technology and promote learning. They are aware that MicroPython is one of the easiest languages for a beginner in programming, and that is why they are working to construct a board that will coincide with the MicroPython development platform. This project includes constructing a user interface that will serve as a MicroPython editor. For this editor, the user will be able to write, upload, and connect via Bluetooth to the Trynkit MicroPython board. Bluetooth will enable wireless uploads from the user interface to the ESP32 chip, similar to the chip seen on the bottom right of the slide. Group effort will be devoted to optimizing the speed of an upload. Firmware corresponding to the project will also be constructed to allow for smooth functionality. Like I said before, Trynkit is devoted to team learning, so there is no surprise that is a goal for this project. Trynkit hopes to gain more knowledge pertaining to wireless uploads and dispersed team management. They hope students and hobbyists can learn more about embedded systems through this platform, and they hope we can learn throughout the course of this project.
Hi, this is Justin B., and I'll be talking about the design and architecture of our project. Our project is multifaceted because we are developing a web app that will connect through web Bluetooth to a development board. The web app will feature a code editor where the user will be able to write MicroPython code that will later be able to be run on the development board. The web app will connect through web Bluetooth to the development board, and once the web app compiles the code, it can be uploaded to the development board. The web Bluetooth will be able to locate and pair with any development boards that are within range of whichever device you are using the code editor on. The development board will have an ESP32 MCU on it, and we will be using all the functions of this to our advantage. Because it is a dual core chip, we will be using one of the cores to maintain a constant Bluetooth connection to the web app once it's connected to it. The second core of the ESP32 we will use to run any of the code that has been uploaded to the development board through Bluetooth to the device. We also want to make sure that when we develop the code, that once new code is uploaded to the device, that the user will not have to do a hard reset to get the code to run.
Hello, my name is Brian Carson, and I'll be presenting the implementation strategy for our Trynkit project. As we already know, the project is split into three distinct components. These components are the web editor, the web Bluetooth, and the MicroPython firmware. Upon further discussion and elaboration, we have decided that this would be the natural progression for our project. Phase 1 being the web editor, Phase 2 being the web Bluetooth, and Phase 3 being the MicroPython firmware. Furthermore, we estimate this process to take place over the course of roughly 12 sprints, our sprints being 2 weeks long each. This would effectively partition our project into an estimated 6-month process, which aligns well with our project goals and restrictions. We estimate the web editor to be completed over 2 sprints, meaning it will be ready to present as an artifact at the end of the first session, followed by the Bluetooth implementation estimated over 4 sprints, which we'll start working on prior to the first session and finish in the second session, and finally the firmware for the rest of the project duration, which would be no more than 6 sprints long. We have also taken the opportunity to break this work down further in terms of likely developer allocation. The web editor has been broken down into text editor functionality and code mirror integration to be implemented at the same time for the first sprint, followed by file creation and project file saving and loading for the second sprint. This would take us into the Bluetooth phase, where device discovery is a focus for the first sprint, followed by base connection implementation in the second, and finish with a file transfer implementation, which would forge the connection between our MicroPython firmware and the web editor from the first phase. Finally, the MicroPython firmware is estimated over about 3 months. This would entail several distinct steps outlined in the Gantt chart, which would be produced in a sequential manner, followed by an allocation split for the final sprint between single core utilization for the Bluetooth and single core utilization for the firmware. We see this as a natural means of progression through the project and believe it to be necessary and sufficient for achieving our goal.
The process we will be using for the entire project will be agile. We will be adapting this process in the form of 2-week sprints supplemented with milestone deliverables. We believe this is the right choice because it allows the team to stay up to date and keep our sponsor in the loop. One of our requirements is to meet with our sponsor on a consistent basis to keep them updated on our progress. The Agile Scrum process would be a natural choice for allowing us to demonstrate our progress with milestone deliverables.
Hello, my name is Vicente Ochoa, and I will be talking about the 2 main risks in our project and how we might tackle these issues in our development process. The first risk is the web Bluetooth upload functionality. Some files, depending on size, may take up to 15 minutes to upload. This will certainly affect the user experience. We will approach this problem by designing the web application to include Wi-Fi and Bluetooth updates. Another potential solution is to compress the files before they're transferred to the development board and decompress once they're ready to run. These 2 plans will reduce upload time and, of course, make for a much better user experience. The second risk is regarding the maximum flash size of the development board, which is 4 megabytes. Our 2 solutions for this are very simple. Either limit the size of the code that is allowed to be written to the board, or simply increase the flash size of the development board from 4 megabytes to 8 megabytes. Now, I know I mentioned 2 risks, but there's a third one that comes from the 2 main ones that I mentioned. These risks require a solution, and the solutions require time to be solved, which unfortunately means that our project may be pushed back, and this will have a significant effect on our project schedule.